In this video, we're dealing with mains AC line voltage, 120, 240 volts. We're dealing with even higher voltages, hundreds, approaching even thousands of volts. And we're dealing with high voltage capacitors. All of these things present a shock hazard, possibly a burn hazard, fire, and are potentially lethal. Even capacitors of any kind can hold a charge and can do so even when disconnected from any circuitry. So please, before you handle any capacitors, safely discharge them. Furthermore, cathode ray tubes and vacuum tubes, as featured herein, are under very high vacuum and present an implosion hazard. Please be careful when handling them. Dropping or scratching a cathode ray tube or vacuum tube can cause it to explode, sending shards of glass. So please wear appropriate hand, body, and eye protection. So finally, do not attempt anything you see here. All of this is for entertainment purposes only. It is not instructional. If you attempt anything shown in this video, you are doing so at your own risk. Enjoy. So in this video, we're going to be creating a dedicated analog XY display. Video today, to give credit where it's due, is inspired by another video by a YouTuber known as 12 Volt Vids. Here's his splash page. This gentleman has been around doing this very well for quite some time, doing mostly videos involving consumer electronics repairs, things like VCRs, disc players, stereo, stuff like that. They're entertaining. I recommend you subscribe to his channel as well, as do I. Did a video about 6 years ago or so where he actually wanted to do the same thing. He got himself on eBay, I suspect, a Heathkit HO-10, and he just wanted to use it as an XY display for his scope clock board, and that scope clock board is the Dutchtronics design. It's worthy of a separate video on its own. But anyway, it's a board which generates X and Y voltages, and basically if you put it on an oscilloscope with XY capability, you will get what you see here. And importantly, he started out by starting with the HO-10, and his idea was to do the minimal modification necessary to have a decent XY display and fix one particular issue of a design flaw, which I'll show you in the schematic, and then just use it as a clock display, because I believe he's a ham as well, but he has no need of a station monitor, so he just wanted it as a clock display. I plan on using my XY display for a variety of things, because I already did a scope clock, and the subject of another video on my channel. One thing I want to show you here is, by the way, I'll put a link to this video in the description. It's rather lengthy, but he goes over all the different parts of the HO-10 as will I to some extent. But one thing I want to show you in this little tiny screen grab is the fact that his vertical isn't terribly linear. Notice how the top half of the clock is squished. So that's going to be important as we decide what to do to turn this into an XY display. We're going to start with this Heathkit HO-10 monitor scope. It's worth probably spending a few minutes about what this unit was for and does. The HO-10 was designed to be to monitor your transmit or even receive signal for your ham radio station. So it would do a number of different things. You could look at the transmit envelope to make sure you're not overmodulating. You could look at just the audio output or just the RF output. On receive, you could look at the quality of the received signal and so forth. So it had a number of dedicated modes to do this. But at the end of the day, the HO-10 was what I'll call a special purpose oscilloscope. Now the HO-10 also had a mode where it could in fact be an XY display, or it could be a plain old oscilloscope. Right now I have it running in its sort of plain old oscilloscope mode where it has an internal sweep generator, and I'm now obviously displaying a sine wave. You might notice, maybe you can notice it's a slightly distorted sine wave, but more on that later. It was not really meant to be a general purpose oscilloscope. Yes, you can tweak the sweep frequency. Right now I'm showing about 200, something like 200 hertz. It can only sweep up to about 150 hertz, and not very useful. Also, there was none of this triggered sweep or retrace blanking rubbish. That's why you can see that happening here. But it was compact and it worked, and most importantly, it used a CRT and it was analog. I'll show it to you running in its XY display mode. So here I've set up the HO-10 in its XY mode because it has both a horizontal and a vertical input in the back, and it just amplifies the signals a little bit and then feeds them straight to the CRT. Right now the horizontal has a 1 kilohertz sine wave, the vertical has a 1001 kilohertz sine wave, and that's why you see the circle or the plot oscillating back and forth. Also notice that the top of the circle is kind of flattened, so the vertical does kind of sort of clip out after a certain amplitude, and that's worth noting later. If I make this smaller and make the gain smaller, I can actually get a slightly more perfect circle. So we know that the scope can do an XY display, but I want to make it into a dedicated XY display. By the way, if you're curious what I'm using to generate waveforms to play with this HO-10, I'm using my UTG 932E waveform function generator. And what's critical is that it's actually two generators in one. There's two channels. They're independent of each other, although you can use one to modulate the other. Otherwise, they're totally independent and can do totally separate things. And their outputs come out here. So it's really a nice little function generator and very compact. I got this HO-10 at an outdoor ham fest, and I am a ham, but I really don't need this for day-to-day operations. Rather, this was really just a case of continuing chronic Heathkit acquisition syndrome. More importantly, perhaps, was the fact that it was the guy who had on his tailgate and was selling it. It was just as you see it right now. In other words, turned on and working. Yes, it was in its case, which I'm not showing you here because it's actually in decent shape. But he actually had it plugged into one of those AC battery things so he could show stuff off, and it was running here, and it actually showed the trace just like you were seeing. So that told me quite a few things right there. First of all, obviously it works to some extent. The horizontal amplifier worked, and because otherwise you wouldn't be getting a trace, and he let me play with the controls so I could see that the vertical section was working because I could move the horizontal position, horizontal gain. Can't see the vertical gain, but that's all right. And focus, yeah, all that, and brightness worked, and that was pretty much good enough for me. So that told me that 99% of this thing was in at least some kind of working condition. And his asking price was very, very reasonable. And so because it was running and because he had it powered on and in this state, I just simply gave him his asking. Amusingly, this is the line cord as I received it, and it still works. So I think the line cord is original. The plug most definitely is not. And I have a feeling I know why someone, some long time ago decided to whack off the plug and sort of splice with electrical tape a new plug, non-polarized of course, onto this. And the reason I have a good feeling I know why this was done is because I happen to have an instance of an unmolested original HO-10 line cord. And it looks like this. This is how it originally looked from Heathkit. And so this plug is way unusual, but what makes it even very unusual is that there's no AC fuse in the HO-10. Instead, Heathkit, I guess, found, I've never seen this on any other Heathkit, but Heathkit found this plug, and if you poke something small here, out pops a line fuse. And but wait, there's more. If you then go to the other side and poke out the hole here, out pops another line fuse. So they built the fuse into the, they found a plug that has built-in, miniature glass fuses in it. And surprisingly, they fuse both sides of the plug, which in a non-polarized plug might make sense because you don't know which is the hot. On the other hand, the problem with putting fuses on both sides of your line, of your AC line, is that suppose whichever side is on the neutral, suppose whichever fuse is on happens to be on the neutral side that happens to be plugged in, suppose that's the one that blows first. The other one isn't going to blow because there's no more current flowing. Nevertheless, the hot is still coming into this side and is still going into your circuitry. So you've interrupted AC to your unit, but you've interrupted at the neutral side, not at the hot side. So there is at least some hot AC still going into the chassis, and that's not terribly safe. So the reason I think this was because probably at some point one of those fuses in the original one blew, and the owner probably traced it down to something wrong. There's something wrong with my plug, not realizing that there were fuses inside. That's just a guess. I can actually push them back in, and they'll make contact now. And so he said, well, something wrong with this AC plug. I'm just going to whack it off and splice with electrical tape some other non-polarized cheesy leftover plug, and that's probably what happened. Yes, this is running on a current limited Variac isolation transformer setup. So let's take a quick tour of this thing as I received it, and I'll sort of talk about a little bit about what I'm going to modify here. There's 5 tubes in here, not counting the CRT. This is a 6BN8. That is a combination triode and dual diode. It's used for a couple of things. It's like an RF demodulator in case you connect this up to look at your transmitted signal. And it is also used as something called a clamper circuit, which I'll talk more about when I look at the schematic with you. This will not survive because we don't need it for just XY operation. This is the 6J11. These are little compactron tubes. This is a dual pentode, and it is strictly used to generate 2 different tones, which you can use during testing. So at the 1000 hertz, this is supposed to be 1000 hertz. I'll let you decide. And then this is 1000 hertz with 1700 superimposed on it. For example, if you need something to modulate your carrier. Moving on. Our rectifier tube, the honorable 1V2, it's nothing but a half-wave rectifier. It's used to generate the extra high voltage on the order of negative 1600 volts or so, which is used to power the anode of the CRT. And if you've ever looked at, I believe it's my HO-18 video, I spend way too much time talking about the 1V2. We'll talk more about that in a little bit. 12AU7, this is a very common tube. It's a dual, maybe it's just a dual triode, and it's used as, together, the 2 halves are used as the vertical amplifier in this scope. As you'll see, we will not use this. Finally, we have the 6C10, and you'll notice the three beautiful filaments here. They're all driven off of one thing, but it's basically three totally independent triodes, except for the filament. The filament heats all three cathodes, but the cathodes are all independent. The three grids are independent, and the three plates are independent. So this is basically three triodes in one glass envelope, and we're going to see how we can use this when we get to the schematic. One last thing up here, the main power transformer here, with all the tubes running and glowing. This thing actually runs quite warm, and so that's of some concern. Hey, at least it had continuity and it works fine, so it wasn't blown. But I noticed that it does run warm when it's powering all this stuff. And of course, there's a bunch of different connectors here, and on the back here, I'm actually feeding the separate horizontal and vertical inputs when this is in XY mode. But that's what's going on the top here. Moving on to the top, we have, of course, the CRT, which is shrouded in its little metal sleeving here, which isolates it from stray magnetic fields. That's a good thing. We may or may not keep that. Some assorted resistor, a very dangerous open socket. If you want to see how I usually deal with this socket, stay tuned. This socket will not survive. You'll see a little bit later. The two big chunky electrolytics here are 40 microfarads at 400 volts. Surprisingly, these things tested pretty much on the spot for capacitance and for ESR. And these obviously seem to work. So I didn't test them for leakage. Maybe they're leaking, maybe they're not, but nothing bad seems to be happening right now. Finally, the tour will complete on this side, which is the perhaps the interesting side, because it's obvious from here that someone has been in here before, since it was built perhaps in the 50s, and someone's been in here. My guess is in the 60s or very early 70s, something like that, because whoever was in here did some recapping. They didn't change the 40 microfarad ones, which I showed you up here. Those are still original, and as I said, surprisingly still appear to work. But stuff like these orange drops here, these are, well, relatively new. They're also the wrong value. They're 0.05s, and I believe at least one of them is supposed to be a 0.15. So, you know, whoever changed some of these caps actually did a good thing by changing some of these caps, and fortunately the values are not terribly critical. These things here are also not original, because they're simply the wrong value, and as is this guy. But I guess it's an ode to the design that the value of the capacitors was not critical at all. Another sure sign indication that someone's been in here is this. So this is original. This is called a couplet, and it's basically a resistor capacitor network. It's a combination of, I don't know, four or five resistors and 3 or 4 capacitors, all connected together in a network, and 3 of the terminals are brought out. And this is used as a phase shifter in the tone generator. The reason I know this has been gone in here is because there's 2 of these couplets, one for each half, one for each oscillator, and the other one's missing, but it isn't missing, it's been replaced. And so if you look carefully here, you can see that these little resistors here, there's 4 little resistors, and there's 4 little disc capacitors here. And this is exactly what is, or what would be, in this couplet. So it's missing the other couplet, but perhaps it failed or broke, and whoever was in here replaced it with the discrete equivalent circuit. That's sort of nicely handcrafted. And it works just fine. The oscillator section of this, the audio tone generator, works just like it should. So obviously then whoever did this actually did a nice job. Apart from that, the rest is fairly original. This coil hasn't changed, the discs haven't changed, the carbon comps are all original. And as far as I can tell, all of the pots, especially the intensity pot here, which is offset, and I actually did a video on this. It's on an insulated shaft because there's actually significantly high voltage on the intensity potentiometer. There's also fairly high voltage on the focus potentiometer, but for some reason they didn't choose to insulate this anywhere nearly as well. Oh well, such as Heathkit. I hate point-to-point wiring for some reason. I don't know. It's mostly because it's a pain to modify or to refurbish. I know people make a specialty of this, and it's not that hard to do. But I just think if we're gonna do something with this, maybe we'll pick a different construction technique. But anyway, that's the tour of the at least unmodified as far as when I got it, Heathkit HO-10. So this is a schematic of Heathkit's HO-10 station monitor oscilloscope. It's again for ham radio use, not very useful as a general purpose oscilloscope at all. I want to go over the different sections of this and show you what we're going to keep and what we're going to toss to turn this into a dedicated XY display. But first, I just want to show you the design flaw that 12-volt vid found in this unit, which caused him some grief the first time he hooked up his scope as a clock board to the horizontal and vertical input. So if we go up here, look at the top of the schematic. Ignore most of this stuff, but over here you'll see there's a socket called vertical input, and that feeds straight into the vertical gain control, which then feeds the grid of half of the 12AU7, which are cascaded together. They amplify whatever you put in here, and they feed that basically to the vertical plate, more or less. There's also on the other plate there's a vertical position which biases the whole thing, so you can move it back, you can move it up and down on the screen. But notice the vertical input here goes straight into the grid through the vertical gain pot. Then further down here we have the horizontal input. It goes into this switch. Now, right now this switch is shown in what's called the sine position, which is really called a sweep, which should be called sweep, because what this is a classic sweep generator, which isn't very useful. I mean, you'd find it in any simple oscilloscope, and it's simply a ramp generator. So you can have horizontal sweep and use it sort of as a classic oscilloscope, and you can adjust the sweep frequency here from about 15 hertz to about 150 hertz. Again, not terribly useful as a general purpose scope, but nevertheless there is a sweep generator in here, and that's what gets fed into the horizontal amplifier and goes into the horizontal plate, or one of the horizontal deflection plates here. And notice that on the other hand goes through a 2 microfarad capacitor, which is fairly chunky actually, and then into the horizontal gain and straight into the and then into the grid of 1/3 of this 6C10, which is just a triple triode. The other two parts of this triode are used here as a sweep generator. So 2/3 of this triode is of this 6C10. Two of the triodes are used as a sweep generator, an oscillator basically generating a ramp, and the other third of it is used basically as a deflection amplifier. But what he found is, so he started out with a switch in this position here, so it got its horizontal from the sweep generator. Then he connected his scope as a clock board to the vertical and horizontal input here, which right now goes nowhere. Then he flipped the switch here to the middle position, which is what you'd want for horizontal input. It's called AF trap here. Don't worry about that. It's basically horizontal in. And what he found is it immediately fried one of the chips generating the horizontal signal on his clock board. And the reason for that was when he flipped this switch over to here, this had enough of a charge in it that it fed its charge back through here into the horizontal input output and into his board and fried it. And so this capacitor being here was a culprit. Ideally this capacitor should be here if you really want to have a capacitor between on the horizontal particularly on the sweep generator. But there's really no reason to have any capacitor feeding the horizontal input straight into the grid, because after all on the vertical there's no capacitor at all. So that's the flaw, and he actually corrects that in the video. Um, well, I want to talk a little very quickly about what we're going to keep and what the rest of the all the 5 tubes here do. I guess we'll start at the top here. This is 1/3 of the 6 BN8, I believe. This is used as a demodulator, a diode, or a detector. So you can see the out. If you're transmitting, you can see the output of your just the audio, and that's another thing you can put into the horizontal if you want. We're not going to be keeping this because again we're not planning on using this for radio use at all. So although 12-volt vids basically just disabled a bunch of this circuitry, he actually kept it here and he kept it all alive, just not in use. I plan on actually removing all the stuff that isn't essential to the simplest possible XY display. So certainly this RF demodulator part here, that disappears. By the way, as does this switch. Then we have the vertical amplifier. This actually takes the vertical input and amplifies it through 2 stages of a 12AU7. And I'm not in love with this because of there's some nonlinearity going on here. I've tried several 12AU7s. They all do the same thing. I played with some of the values, as did he, to try and get this to work better. He eventually kept this section and he basically removed the cathode bypass resistors and caps. He just removed all of those and found that it worked a little better. I will see. I don't think I'm going to be using this for my vertical amplifier. So the 12AU7 will probably go. The other 2/3 of the 6BN8, again, the first third was the RF modulator, the other 2/3 are being used as something called the clamper. This is a clever circuit because of the way what this scope was used for. If you weren't transmitting or receiving anything, and you had this scope on, you wouldn't see anything. You would see typically just a dot because there'd be no horizontal deflection and no vertical deflection in some of the modes, in some of the trap modes here. And so you'd have a dot on the screen, which is not something you want to keep on your screen for very long because it will burn a dot into the phosphor. So the idea of the clamper here was if it detected no input at all from the antenna, I guess, what it would do, it would allow this tube to bias the vertical deflection all the way off the screen. So you'd still have a dot, but it wouldn't be visible because it would be deflected way off the screen. It's an interesting idea in an XY display because if you're not putting in a signal, you don't want a dot there. Nevertheless, the way this is implemented isn't going to work for us, so I'm going to delete this as well. So this all goes away. So this clamper part goes away, this RF demodulator goes away. We'll talk about the vertical amplifier a little bit more as we get into this. I'm going to go down here to the tone generator, which is a dual tone generator. This thing, this is where those couplets are, which I showed you. One of the original owners decided to replace the couplet with exactly what's inside, which is this. And the Heathkit is kind enough to tell us that this is a combination of 500 picofarad caps and 470K resistors arranged like this. Very nice of them. So maybe someone broke their couplet and had to recreate it with discrete parts. Nevertheless, this is 2/2 of a 6J11, so a dual pentode. Now you got to generate 2 different tones. You got to generate. The idea was to generate a 1 kilocycle tone and a 1700 hertz tone. And you could use either the 1 kilocycle tone alone or use both of them beating against each other. Tone output winds up here, and you could then plug this into whatever your amplifier, your microphone input, or whatever you want to use this to modulate a signal. Just on the side, it's kind of clever how they only had 1 pentode each for each tone. Now normally if you want to create an oscillator, you do something like this, which takes 2 amplifiers and cross-connected in a very classic oscillator. Here they only had 1 pentode available for each frequency, so they were able to get the pentode to oscillate, as I understand it, by feeding it back 180 degree phase shifted output signal, and this caused it to oscillate. And they did the same thing here, and that's why there were two couplets. We don't need a tone generator. This was not a very good tone generator. It didn't have to be. It was nowhere near a perfect sine wave if you actually looked at it, but it was very typical of what Heathkit would do to try and take what would fit, in other words, what they had on hand, which probably was a whole truckload of 6J11s, and say, okay, how do we do a two-tone oscillator? And they made it work. All of this gets deleted. We do not need any of this for our XY display. Moving here, this is the power supply section, and I'll just move up a little bit to the CRT high voltage section here. So this we're going to keep for the most part. Again, the primary here. Here's where you remember I showed you the original plug with both of its fuses. Well, they actually showed it here where it belongs, next right on the plug. Obviously, we're going to replace this and put an internal fuse inside, one internal fuse on the hot side inside the unit. They also have a couple of bypass capacitors. We will probably discard those. I'm not a fan of death capacitors coming off the AC line. Anyway, the primary, secondary, there's a 3.5 or 4.5, whatever you want to call it, secondaries. The top one here is used to generate something under of negative 1500 volts. This is very classic. You'll find this in any oscilloscope, some method of generating a high negative voltage, and that's to run the cathode here, so that gets the electrons going. So it feeds the cathodes a whole bunch of electrons at a high voltage. Very typically, you'll see 0.1 capacitors here at 1600 volt 0.1 capacitors. These happen to be 0.15. Okay, so this is a little bit of a filter here. This is our venerable 1V2 half-wave rectifier tube. More on that later. So anyway, this just generates a high negative voltage to feed the cathode, feed the intensity control, which feeds the cathode, feeds the focus control, which feeds the focus grid here, and with reference to ground. So this is a big voltage divider, and by varying those two voltages, you adjust the intensity and focus. And that's this. The 1V2 I'll mention, its filament only needs like 1.2 volts. So there's a tiny little portion of this winding which is tapped right away and generates a tiny little 1 volt voltage. However, the whole thing is offset from ground by 1200 volts AC, and that's how we get the high voltage. So you got to be really very careful when you're looking at this. So yeah, there's only 1.2 volts across the filament, but the whole thing is biased at over 1000 volts with respect to ground. So be very careful. Moving on down, another secondary. This is used to generate B plus for the tubes for the most part. And this is, interestingly here, they're using what amounts to a full wave bridge. And these are the 240 microfarad caps, which I said seem to be working just fine. And so our main our B plus high, it's called, is 580 volts or so. And that actually only feeds one thing here that we might want to use, and that feeds the second stage of the second vertical amplifier, as well as the horizontal and vertical position biases. Then the other going down here, we're not at ground yet, so the other side here is a lower voltage, and it comes off here and gets filtered by 220s here, and that feeds the anode essentially. So that's your high voltage. It's positive, and that gets the electrons moving from the cathode through the anode, which is a cylinder with a little pinhole on it, and sends them off to the phosphor, sends the electrons off to the phosphor. And so this is a lower voltage. It's about 280 volts here. So the difference between the cathode here minus 1000 or whatever it is, and plus 200 yeah, you get enough voltage to get the electrons moving. This is also used, goes through another resistor, 1 watt, and more filtering here, and this would be generating about 160 volts DC, and to feed the pilot lamp, the AC, the on-off lamp. An interesting idea. We'll talk more about that later. But really, this whole affair here provides voltage for the tone oscillators, which we don't care about, and the sweep generator that we don't care about. That's the only thing this thing's doing. So this portion of that I'm going around here now, this portion of the power supply is getting deleted. As you'll see, the pilot lamp, well, one of the nice things about running the pilot lamp off of this is at least it tells you that your B plus supply is alive. That's a good thing. On the other hand, I don't want to create another section of B plus just to run a pilot lamp. So this will be simply connected to an appropriate resistor to our primary here to show that the AC has been switched on. Finally, not finally, one more winding here. This is the filament winding for the CRT. And it's nominally 6.3 volts AC, which is what the CRT runs, and that goes here and here to the CRT filament. And you might wonder, why is this its own winding? Why they have another winding here with 6.3 volts AC to feed all these other tubes. Why don't they just use that? And the reason is because although they're feeding the filament here 6.3 volts AC, they're tying it to the high voltage cathode stuff here, and that's because although you only want a little bit of voltage to run the filament, you don't want a huge differential voltage between the filament and the cathode because it could arc. So you want these two to be, you want the filament to be biased at very nearly the cathode voltage. So there's not much potential difference between the two. Yet the filament itself is at a low voltage, and that's what this connection is doing here. Obviously, you couldn't do that and feed all the other tubes what amounts to super high voltage, so it gets its own rather chunky secondary winding, because this winding has to be properly insulated inside the transformer from everything else, because they know that it has a very high bias voltage on it. And finally, the final winding here, green, is your conventional 6.3 volts AC, which is feeding the filaments of all the other tubes that are not the CRT and not the 1V2 rectifier. So all the other tubes you see here have their filaments fed by this. More on that later. So what do we keep here? So we decided to remove all of this. I had a choice here. What do I use to actually do deflection amplification? And I decided to scrap the dual 12AU7. 12 volt vids kept it. I decided no, I'm going to scrap this entirely because I wasn't happy with the way this was behaving, the nonlinearity. I wasn't going to start futzing with it. So I decided to completely scrap this. Perhaps this would have been better, would have provided more gain if I had made these a single 12AX7 and used both halves of that, because I believe the 12AX7 has more gain than 12AU7. But in the interest of simplicity, I decided to scrap this completely. So what am I going to use? Well, I decided at that point, why don't I do this and advertise it as a one-tube XY display? That seems like a nice clickbaity thing to have. So how do I reduce this to a single tube? So I scrap the vertical amplifier, I scrap all this other stuff up here, except the horizontal position, keep that. But I scrap all these tubes here. I scrap all of this tone oscillator stuff, which leaves me with, apart from the CRT. By the way, when I say a one tube XY display, I exclude the CRT. Okay, so that leaves me with two tubes. It leaves me the high voltage rectifier, the 1V2, and it leaves me with all this. I don't need the sweep generator, so why don't I repurpose one of the three sections of the sweep generator to do my vertical amplification? And furthermore, I'm going to redesign this so it exactly mimics the horizontal amplifier. So the horizontal and vertical amplifiers are now going to be symmetrical. and let's do that. So before I show you the completed final article of the totally modified HO-10 and its internal guts, totally rebuilt and modernized, and before I show you the modified schematic of the thing, I just wanted to mention in the end, in his video, 12-volt vids, he wound up pretty much rebuilding the vertical amplifier section with the two halves of the 12AU7 pretty much, from I can tell, to the way it was factory, and that's fine. And he improved his linearity, his vertical linearity, by putting in apparently a fresh 12AU7. I've tried all the 12AU7s I had. I never could get it perfect. I don't think he could either, even after letting it warm up for forever. It's not just quite linear. So this is why I took this. That's one reason I took this approach. Again, my goal was to totally simplify the circuitry to the greatest extent possible, minimize the component count, remove anything that wasn't absolutely essential to creating a decent XY display. And so here, again, in the interest of bringing you the lowest in production quality values, is my modified schematic. And we'll start at the power supply section, which you see here. Most of this was unmodified, actually, because we still need power. Obviously, the on-off light, the power indicator, I moved from one of the high voltage sections to the primary section, put in a 30K. Most importantly, I got rid of that. I actually put in a 3-wire line cord, which I forgot to show the ground here. This is a 3-wire plug. The hot goes straight to an internal fuse inside the chassis on a fuse holder that I mounted. Then as it should, then it goes to the on-off switch, which is on the intensity control, and then it simply goes to the primary of the transformer, and also, of course, to the pilot light and a 30K resistor. Nothing terribly exciting there. Removed the unused sections that I didn't need of the power supply on the tube filament string. You'll notice there's only one tube left, and that's a good thing because one of the side effects of having all 5 tubes running is that this power transformer in the end would run very hot, much hotter than I would ever want to see it run for any extended length of time. And I attribute that to the fact that it was drawing all these filaments on. So now that it has only one filament, you'll see it's going to run a lot cooler. Apart from that, the rest of this section is pretty much unmolested. This 1V2, yes, it is a second tube, as you'll see, but we'll deal with that. Apart from that, it was rebuilt and left the way it was. The high voltage section of the CRT is essentially still factory design. Nothing has changed except all new components, as you'll see. This is where things start getting a lot simpler. So off on the side here, the tone generator is obviously totally gone, and all the other tubes that aren't necessary are only gone. So the only thing that's left in terms of tubes, the vertical section, by the way, the 12AU7, that's gone. So again, I decided not to use the cascaded 12AU7 sections because I could just never get the linearity 100% as I wanted it. So in the end, I rebuilt a new vertical out of 1/3 of the 6C10. If you recall, there were 2 sections of 6C10 here on the sweep generator. Didn't need that anymore. So I used one of those sections here, and that's our new vertical amplifier. And it actually mirrors perfectly the horizontal amplifier in terms of the design. So the circuitry is absolutely symmetrical. The horizontal and vertical sections are totally the same. They're obviously just going to different plates. The vertical position here is now the same as the horizontal position here. Nothing else. It's exactly the same. So it's about as simple as it gets. So with that, now let's take a look at the finished article. So here's the simplified and modified HO-10 turned into a pure XY display. And you'll notice immediately that 3 of the controls are missing because they're no longer needed. In fact, they have no longer any place to go to. Neon bulb is working fine, of course. It's a brand new neon bulb. So we have the bare minimum of controls we need. We still have intensity. We still have focus. Focus and intensity are the only two pots that are original factory. The focus is giving me a little problem. I can't even get the knob on. I believe it's a 1 meg pot. It's linear. It's gonna get replaced. All the other four pots are brand new pots, and they're buttery smooth. So here I've got the two sine waves exactly 90 degrees out of phase, which gets you a circle, and I'm not getting any more flattening. I've got perfect linearity all around the circle, and that makes me happy. So now what I'm going to do is make it rotate again. Let's change phase to nothing, which gets us a straight line, of course, because now I have two sine waves that are totally in phase, and at the same frequency. And now we're just going to make one of them 1 hertz off. And so there we have our usual two sine waves that are in phase, but one's running at 1 kilohertz, the other one's running at 1001 hertz, and that of course causes it to rotate. So now we can look inside and see what we've done here. So moving right along, where's the pointer? So all of the connectors in the back are gone. New 3-wire line cord, grounded of course. Hot goes straight to a back panel. Fuse holder, and that's really the only thing left on the back panel, as well as the horizontal and vertical input RCA jacks. I didn't convert them to BNC because I wanted to keep it sort of period appropriate. Anyway, a new AC section. This is a CL90 inrush current limiter. I don't know why I had an extra one, so I threw it in. Maybe it'll help. Of course, it's the original transformer. It's running stone cold, which is nice, because you'll notice all of the tubes are gone. By the way, the can capacitor was a 4-section can. Now 2 of those sections have been replaced by an adapter cap and 2 caps. There are actually 2 more caps like this on the other side. I couldn't put them here because those 2 don't go to ground. As you probably saw from the schematic, the 240s are not connected to ground, so I couldn't put them on the adapter cap, unfortunately. Apart from that, there's no more tube here. It's empty. There's our 1V2, and there's our 6C10, which is acting as both a horizontal and a vertical amplifier, and one unused section. But wait, I hear you say. You promised me you would do this in 1 tube, not counting the CRT, of course. Yet I see 2 tubes. Aha, so there. No more 1V2 high voltage rectifier. And then finally we have our 6C10 here. A little bit on the 6C10. There is a downside to using a 6C10. And, it's not perfect. It does have enough gain to run the CRT properly and not distort, so I like that part a lot. But basically it's one of these, I think it's a 12-pin compactron. Here's another one. And I guess the one downside I found is that these things are wickedly expensive if you have to replace it. For some reason, they're becoming unobtainium. So what is this thing that I just plugged in to replace my 1V2 tube rectifier? Well, it's a completely potted and sealed little cylinder with 9 pins coming out of it. And it's called an ECG 511 or an NTE 511. Rest in peace, NTE. But what it is, it's basically a high voltage diode that's encapsulated, and basically only 3 of these pins are in use. Right, is the pinout for our little potted substitute, solid state substitute for the 1V2 half-wave rectifier. And as you can see, all it is a potted diode in a 9-pin epoxy potted thing. And I put it next to, on the left, the pinout of the original 1V2 tube for comparison. And so you'll notice on a 1V2, pin 1 and pin 9 are connected, internally connected to the anode or the plate, and pins 4 and 5 are in fact the heater supply and also form the cathode. So your transformer filament goes to pin 4 and pin 5, heats the filament, and is biased to a high voltage so that electrons come off and are attracted to the anode. And that's really just how the rectifier works. On the solid state replacement, basically the same thing's going on. Pin 1 and 9 are internally connected together and go to the anode of what's really just a solid state high voltage diode. The cathode of the diode goes to pin 4, but it does not go to pin 5, because if you just drop this in instead of a 1V2, you're still going to have filament voltage coming from a transformer going to pin 4 and pin 5, which is not going to be used. Nevertheless, if you were to connect the cathode here to both pin 4 and pin 5, internally that would short pin 4 and pin 5, and your transformer filament winding would release magic smoke. So that's why they only connect it to pin 4. I believe I read that this thing, the ECG 511, also known as the NTE 511, rest in peace NTE, is rated to 9,000 peak inverse volts, I believe. In any case, it's designed to be a direct plug-in substitute for the 1V2 rectifier tube. And if we look at the 1V2 rectifier tube, we look here and we look at absolute maximum inverse plate voltage, and DC is 6600 with an absolute maximum of 8250 volts maximum across a 1V2, which is impressive. Obviously, we don't need anything like this or even 9,000 volts, but that's why I believe this high voltage diode here is rated to 9,000 volts. And it should be obvious that this is nothing that you can't make yourself with a bunch of, say, 1N4007s in series to get you, in theory, 9 of them in theories would match this. That seems a little bit unwieldy. Anyway, I'm happy I have one of these, and it does work perfectly as a 1V2 substitute. The intensity control is still stock. It's still insulated, which is a good thing. It's perfect, exactly the way it was on the original HO-10. The focus control is giving me issues. Its knob doesn't want to go on for some reason. I don't know why. Plus, the pot is feeling a bit gritty. I don't know why I reused it, but I did. But I'll probably swap it out. And then all the other pots are new miniature types. Basically, the X and Y gain and X and Y position control are new more miniature pots, and they're of course buttery smooth. So this focus pot is not long for this world. Moving to the top, I needed more room because I needed more room, and I found just enough room under the CRT so that nothing is actually touching the CRT. And there's two parts to there are two tags or strips to this. This strip here is exactly the mirror of the horizontal one here, except this is, of course, the vertical section, and it connects to a different section of a different triode in the 6C10. So the horizontal amplifier is here, vertical amplifier is here, and the one tube that runs it all is still the 6C10, exactly the same. This section here is the high voltage stuff that goes to the CRT's cathode and the CRT's anode and the CRT's focus grid and the CRT's filament, by the way, which is here. And I arranged it so that all of the wires coming from the CRT go to this board on the other side, come out, and the wire lengths are a little bit excessive, so they come out there and they get looped once because I kept them too long. Because originally I had the CRT mounted far away from the chassis, but I didn't bother shortening them. Doesn't seem to care. And I put in a much safer Cinch Jones socket. This is the same socket type I used in my scope clock project if you want to see more about that. So go look for my scope clock video and you'll see the exact same socket. Using modern, or at least more modern componentry, all new componentry. I don't like point-to-point wiring, so I tried to change it a little bit and used tag strips here, and there's one here which I'll talk about. I like that construction method better because frankly it makes it easier to sub parts or to service it. It does mean a little more rat's nest of wiring though. Anyway, starting at the beginning, if we looked at that power supply section, these are the high voltage caps which develop the negative several hundred volts or 1,000 volts. Actually, no, Heathkit told for 0.15 at 1,600 volts. I only had 0.1, and so I got some 0.047, and I put a 0.1 and in parallel with a 0.047, and that gives me 0.147 instead of 0.1.5, and works fine. The filter dropping resistor, and that becomes the entire high voltage section. And it's fed by, well, either the 1V2 or the new solid state rectifier, which allows me to still claim this whole design only uses one tube, excluding the CRT, of course. Anyway, apart from that, this is the B plus supply up here. These are 239 microfarad at 450s. These are that would replace the 240 mics that you saw in the original design. The two that are on there are two caps that are on the adapter cap, which is facing underneath here. Those are 20s, which are used in the other half of the B plus supply. I couldn't put these 39s on the adapter cap because these are not referenced to ground. Apart from that, those four diodes, there are two diodes in series. These are 1 and 4 007s. Two of them, two sets of two in series, and that's perfectly per the original schematic. And then new resistors as appropriate. It's exactly the same as you saw. The power supply section is pretty much exactly the same. Then we come to, you can see it. Let's see if I can. This strip here. This is the horizontal amplifier section, and it connects to the 6C10, which is here. So 3 wires go from the 6C10, basically cathode, grid, and plate, and connect into the various parts of parts that go all around it, bypass capacitor, bypass resistors, stuff like that. And those are mounted on the tag, again, exactly like the last schematic you saw. So that's the entire horizontal amplifier section with a third of the 6C10. By the way, this socket in the middle of the picture is where the 1V2 and now the solid state rectifier is plugged into. So that basically, oh, and of course this is the horizontal and vertical input, what used to be the tone output, which was the middle conductor here. It goes nowhere, but I kept it on the thing. That could someday be a Z input to my XY display. In fact, it occurred to me that I have an extra 6C10 unused triode, and I have an unused input here. What could I do with those? Well, I could bring it into and amplify it and turn it into a Z-axis or intensity modulation with very few additional parts. And what do you know? I have room for at least a few more parts on my strip here. Anyway, so that's this side of the rebuilt XY display. And yeah, it is a bit of a rat's nest, but I prefer that to point-to-point wiring. So displaying Lissajous patterns like I'm showing here, while makes cute demos, is not terribly useful. I'll be using this with a two-channel D to A run by a processor, so I can display various graphics. The other thing is, while stripping all of this down to the essential XY display, one of the things you saw I removed was the internal sweep generator. So you can't have a horizontal sweep anymore, at least generated internally. But suppose you still wanted to use this as, I'll call it a very classic and bare bones oscilloscope to show a signal. What can you do? Well, nothing could be easier. You generate your own sweep. Right now on the horizontal, I've got a 1 kilohertz sine wave. Let me turn it back on. And on the vertical, I have a 4.001 kilohertz sine wave. But if I go back to the horizontal and suppose instead of a sine wave, I change the shape, let's change it to a ramp. And that's here. And not a lot changes on the display. And you notice because the ramp is in the shape of a pyramid, what we really want is a ramp that goes up and then sharply comes down, which is basically the retrace on a classic oscilloscope. And so what we want to change is the symmetry of this waveform. So I'll push symmetry here, and I'll move this so it's basically looks like that. And now, if you'll see on the display, I have my classic sine wave being displayed on an oscilloscope. I still don't have any of that retrace blanking rubbish that you'd find on any other oscilloscope, but this is basically bringing this oscilloscope back to the way it was as far as generating an internal sweep. Just generate it externally. And by the way, we can show other stuff. For example, on the vertical, instead of a sine wave, suppose I wanted to make this a square wave. Well, here's our approximation of a square wave, at least as far as this oscilloscope is concerned. I know the waveform generator is creating a very nice square wave, but the frequency response of the scope, well, still leaves a little bit to be desired. So I know what some of you Heathkit fans are thinking right now. You're thinking, I can't believe he took a perfectly working Heathkit product and totally scrapped it and tore it apart. And frankly, you'd be right. So this is the new unit I've been showing you, and of course, the original one is still around and still works perfectly. The new unit was an eBay basket case, which was non-functional. Some of the pots were frozen, the thing was rusty, and a few of the tubes were simply not there or not working. So that became this unit.